Hi everyone, welcome to another episode of the Data Standard Audio Experience. Today I'm here with Ken Tidwell, the VP of Security Engineering at Sumo Logic. And today we're speaking about data scalability. And I'm so excited to hear more about this topic from your perspective, Ken. So welcome to the show.
Hi, thanks. It's good to be here. Thank you for having me.
Yeah, thank you for being here. And could you just go ahead and introduce yourself to our audience and tell us more about just the things that you're working on and what led you to where you are today?
Okay. I've been around computing for about 40 years, doing different things. The thing we'll be talking about today is a thing called SIM, which is called Security Information and Event Management. It's a really bad name for what it is, but it's essentially a big data application that pulls in logs from all over a network, and with the goal to protect that network from potential harm. So essentially, you pull in all the logs, you apply all the AI techniques known to man to identify threats. You raise those threats to humans or to increasingly machines, and then those threats are investigated. The ones that turn out to be true, you're going to want to either remediate them, like block the threat from happening again, or repair the damage that happened, or report to interested parties that such a breach happened. I was the chief architect at a company called ArcSight when the SIM was defined, so kind of created it. And my history with it goes even farther back. What a SIM really is an expert system. And expert systems were an idea that was popular in the mid 80s. And I was actually the head of user interface at a company called IntelliCorp, which was the leading company in expert systems. It was one of the first two AI companies created in Silicon Valley a long time ago. But an expert system basically tries to encode the knowledge of an expert in order to examine data and come to some conclusion. The original expert system shells were the first place that objects showed up for most people, the first time they ever encountered object-oriented programming. And they had what was called a rules engine, which is basically a big if-then construct. If you see objects of this sort, and it can be one object or several objects that are joined together, then you want to do some action. Frequently in the original expert systems, it was create another object that encoded some kind of inference, something that you knew about. And those were being used for originally, like even before I came along, they were being used to do medical diagnosis. And they went on to be used to help isolate the AIDS virus. And they went on to do things like plan battlefield deployments for the US military for about the next 20 years, design naval blockades as part of Desert Shield many years ago, that kind of thing. That's what the original IntelliCorp expert systems were used for. But even in IntelliCorp, people had noticed, okay, what you're doing when you're like entering some symptoms, you're creating objects, and they were very simple objects, something called frames. So they basically they were more like a dictionary in Python or something like that. And they had some more sophistication than that, but not a lot. They were not like a C++ object or even like a Java object. So you'd create these simple objects to state these facts, and then the rules engine would chew on them and create more facts, hopefully like a diagnosis. But people had noticed, hey, it'd be really cool to attach one of these expert systems up to output from machines, like at a factory. Like we receive more inventory, or this machine is broken, those kind of events, and then reason about it. And people built the first prototypes of just-in-time inventories and real-time pricing of airline tickets and the very first fraud detection using that system. That system ran fairly slowly. I've got notes I got to consult to keep myself honest on these numbers. It could consume, like if you had a really good tailwind, it could consume maybe 5 events per second, which was equal to about 1 kilobyte a second, or about 86 megabytes a day. And those ran on what were called list machines, which were the very first. I mean, they look very much like the laptops that we're using today. They had mice, they had screens, they had pointers, they had windows, but they ran about, in today's money, about $1.6 million a piece, and they were PCs. So they were kind of expensive. So people mostly did prototyping with it. People thought about the ideas and whatnot. Expert systems never really went away. They went and became embedded in control systems like an inventory and just-in-time factories have expert systems embedded in them that are handling the flow. But selling expert system shells, like what IntelliCorp did, kind of faded away in what was called the AI winter in the late 80s. Through the 90s, I did other things. I built one of the first server-side Java applications and explored doing back-end, high-end scaling of servers and whatnot. And then in early in the new century, in like 2001, I ran into ArcSight, and they wanted to build something in security. I didn't really know anything about security at the time, but when they described what they wanted to build, it was an expert system that was going to take in real-time events, and it had all the same interesting things that ours had back in the early 80s. So I was like, okay, this could be fun. Let's do this. And we built it, and it worked fairly well. It encapsulated the expert knowledge as rules, just like before. But we didn't have the concept of like creating objects in a frame language. So instead, we created something called an active list, which was a kind of a blackboard system where facts could be posted to it and read from it by the rules. So that if a rule figured out, hey, this machine has been compromised, it could have malware on it, that could be put onto an active list. And then other rules could say, okay, we don't trust that machine anymore. Anything that it does that looks the least bit shady, we're going to flag and try and establish whether it really has malware on it or not, for instance. But it was essentially still very similar at the start to the original expert systems. The scale had gone way up. Now we're running, this is probably about 2003, we were doing about 10,000 events a second, or about 2 megabytes a second, or like 175 gigabytes a day. Which was pretty good. This was still running as a single machine server. It had no distributed qualities. But then we started to add in additional. Well, there were things that changed. And the expert system was operating on like objects in memory. But when we were starting to deal with that many events, that many objects flowing into the system each second, we had to redesign the rules engine so that it understood that objects were moving in and moving out of memory. And time became an interesting component. How far apart were the events? So the rules engine was pretty heavily redesigned. I got lucky and I got to work with a chap who had built the rival rule engine to IntelliCorp's rule engine. And he built the one that we used at ArcSight, and that was a lot of fun. But then we started looking around at some of the newer things that were going on, like being able to do pattern discovery. This is a thing that was pioneered by things like grocery stores. The grocery store likes to analyze receipts when you go to the grocery store to buy. They want to figure out what objects typically show up in the same receipt, like milk and bread and peanut butter. And then their goal is to move the objects as far away from one another as possible. So you have to walk through the whole store to buy your things that typically go together. And their hope is that you see something else that looks good and you buy it. Say they sell more stuff. But the way that they establish that the milk and the bread and the peanut butter go together is they do something called pattern discovery. You say, okay, these things frequently show up together on the same receipt. So it had occurred to me that we could do that with security events. If security events of a certain type frequently showed up in a transaction, that may mean that that was a footprint of a particular piece of malware or a particular kind of attack. And that worked out really well. It really did pull together signatures of things that were going on in your network that you'd never seen before. Going forward, people brought in even more interesting techniques and came up with really clever ideas, even for using the stuff that we'd started at ArcSight. I went away after about 5 years of working on that problem and did other things for a while. And then it's about 6 years ago, so that would have been like 2015, my wife had gotten tired of me hanging around the house. So I hit up LinkedIn looking for a new chief architect gig. And the first thing on my inbox was somebody looking for a security chief architect. So I was like, that's why I'm here. So I replied, and it was this guy named Dave Frampton. And he had an idea for a new technology to do investigation, because you got this expert system running and it says, hey, I think this is wrong. And the human has to decide if it was right and what it meant and what you should do about it. And that involves an investigation. When I left ArcSight, it was clear that was the next piece that would need to be built, but no one had ever built it. So we fast forward another 10 years and it was still not out there. So we started a little company to build that, and it worked out fairly well. Again, trying to deal with scale. The issue with investigations, particularly now, is that frequently you'll run a query and you'll get 300,000 log messages back, and a human has to make sense of it. A typical security investigation now will take between 1.5 and 3 hours. But if you do the math on how many people you've got in the security team and how many incidents they need to look at, they have about 8 minutes to look at something, and it's taking them 1.5 to 3 hours to look at it. So we set out to try to do that, and we built some technology that would do very fast queries and do some interesting compaction of the data. Essentially, we would take each message and divide it up into its factors. Like, this talks about this person, this talks about this machine, this talks about this kind of an incident, like an attack or a data flow. So we pulled all the individual pieces of the messages apart and aggregated those. So when you ran your query and it had 300,000 matches, what you got was a summary of the entire 300,000 in like a page or two, saying these were the people that were involved, these were the machines that were involved, here's interesting incidents. And it worked fairly well. I could do investigations on networks that I knew nothing about in a minute or two instead of 3 hours. And we frequently found serious incidents. But it was deemed by the market that was a feature, not a product. That needed to be a feature on top of a SIM. So we went looking around to see if somebody could buy us. Sumo Logic had been founded by guys that I worked with or that worked for me at ArcSight. And their original charter had been to build a SIM, but build it in the cloud. And building a SIM in the cloud was a really attractive thing. One of the hard things about ArcSight was that it was all constrained to one server, and the people that we were selling to often didn't have a good notion of how much data was involved in protecting their network. So they would have to kind of stick a thumb in the wind and buy a server of this size with this much memory and hope that they were right. And they were almost always wrong. And then it would run at the very edge of what it could do and whatnot. So that was frustrating. So moving all that up to the cloud, where you could auto scale and you could have as much memory as you needed, you could build technologies like what we've been building at FactorChain to deal with large amounts of data and queries, was really appealing. So the VCs funded the guys to go do that. And they almost immediately changed tack, and they went after just kind of generic data lake, more like what Splunk is famous for. And they built a very good platform for that. Enormous amounts of scale, enormous amounts of querying, but they kept being pressured to, where's the SIM? We still want you to build a SIM, and we think there's a big market. The SIM market by this time had grown to be about $5 billion a year, and Sumo really should have carved off a chunk of that. So when they acquired my company and Dave's company, that's what they wanted us to do, was come in and build a SIM. So we kind of started, it was very hard building it up. So eventually we reached out and acquired another ArcSight descendant called JASK that is in Austin. And they had other pieces of the puzzle. So we put those together. And since then, we've acquired more companies because there's more things that have added on to the SIM. But we put all those together. It's now a really competitive SIM and beginning to get traction. But the scale went up again quite a lot. So going from our 175 gigabytes a day back in 2003, now here in 2021, a single customer on a Sumo Logic SIM is sending us about 1 million events per second, or 277 megabytes per second, which works out to about 24 terabytes a day. And let's talk about that a bit. Back when we built ArcSight, the original SIM, it would take in raw logs, but it would do what's called parsing and normalization. So that's, you take the log and you divide it up. You basically build a dictionary out of it. And you normalize it. All of the messages are now going to have the same fields. And the hard part is mapping from that original message into that normalized schema. So there were things that were interesting about that. That's all kind of my fault that it was done that way. And there are things that work really well, like rules. Love that. Now they know where to find everything. They know what the fields are called. It works great. But investigation hates that, because the messages no longer look like whatever you're used to. They don't look like your firewall messages. They don't look like, your IDS messages. They've been normalized into this gobbledygook, and you don't know where to look at it or what to make of it. So that was a problem. And we were not retaining the original log message. So there wasn't even a fallback to go look at that and see if you could make heads or tails of that. So at Sumo, all of that has kind of been addressed. Sumo collects the raw logs, stores those. So that's our 24 terabytes. But then we parse the messages into dictionaries that match the original log format. So like if you're reading a Palo Alto firewall log and it wants to call the source IP SRC IP, then we call it that. No change to the terminology. Whatever you're used to, that's what you're going to see. But then we take that parse dictionary and we map it into a regular normalized dictionary, which is really, like I say, really good for rules. We've retained the first parsing using the original source devices nomenclature. So that's really handy when you go to do investigation, because your security engineers can read that, understand what it is. And we still have the raw original log. So, you can always reach back and look at those if you need clarification. But that all comes at a data cost. The normalization process typically produces around 2 to 4x the data that the raw logs were. So that's somewhere between 48 terabytes a day and 72 terabytes a day. So now we're ingesting up to like 100 terabytes a day. So that's 3 petabytes every month going into the system. And Sumo does really well with it. It totally just shoulders it, brings it in, indexes it, can search it very fast. That part works great. We use the JASC implementation of the rules engine, which is built around Kafka streams. And that does a good job of laterally scaling and dealing with enormous amounts of data. So it's actually keeping up with all of that data per customer, but it's a laterally scaled multi-tenant system. So sure, you talk about that, one customer is sending us 1 million events a second, but we have 100 customers. So we're getting more on the order of maybe 80, 60 million events a second going through the rules engine, and it's chewing it up and doing a really good job of it. Anyway, so that's kind of been my journey, going from, 1K, 80 meg a day of data to, 100 terabytes of data a day.
Yeah, definitely. And it sounds like a lot of different things that you've been working on in your current role and also some of your past roles. And it's clear that you're very passionate about what you do. And do you have a favorite aspect about your role, or just a favorite thing that you like to do that you enjoy doing at your work?
Well, it's just that the thread is doing stuff that really has a high impact. Like back at the IntelliCorp days, the fact that expert systems were being used to keep the space shuttle flying, go track down AIDS, things like that. I really like that. In the IntelliCorp days, it got more serious. We started to be involved with military operations, with all the spies and she's on the planet, and the impact it was having was honestly a little bit worrying, a little bit frightening. It puts an edge on your work when you know that it's being used for stuff like that. But I enjoy that. I enjoy the fact that it has this high impact. I guess the thing that got me started and made me come out to Silicon Valley and work for IntelliCorp is that I'd wanted to work in AI originally. And so joining one of the only two AI companies on the planet was a good thing. I ended up doing user interface work then. And since then, I've mostly done either back-end work that would be closer to data mining or large-scale server operations. But I've always kept an oar in on the AI side of things. So working to build out and design the rules engine for ArcSight, working on pattern discovery. And now at Sumo, we have a thread of that. One of the advantages you have once you move everything up into the cloud is we have visibility across multiple organizations. So when we were working at ArcSight, everything was in a silo, right? You sold the software to a customer, they bought some hardware, they deployed it, they could see their stuff, and that's all. At Sumo, we treat the privacy of the data very, very seriously, but we have visibility across. So we have an effort called Global Information Services, that GIS, that anonymizes data and looks for trends. So for instance, around security data, it'll look for unusual patterns of security information coming in and say, hey, nobody else is seeing this. This might be something unique to you. This might be somebody trying a new attack. It'll flag that. As part of the JASC data flow, they're creating something called an insight. This has to do with some algorithms that people like Exabeam initiated, where you take the flow of security events and you assign a severity to them, and then you group them around often what's called an entity, like a machine or a human. And if the severity grows too high, then you know there's something going there. It's like there's smoke, there must be fire. It often doesn't have any idea what it is that's going on, but it thinks there's something bad going on. And that'll create what's called an insight. So our GIS team can look at insights being created across customers and say, I think this insight really is a fire, and this one is just smoke with no fire. So it can rank with confidence which insights you should look at first. So figuring out how that would work, trying to come up with more things like that we can do with this global view of data has been really interesting. So those are the kind of things that I enjoy. I like building things, but I also like designing things, and I like inventing things. I have piles of patents around all these things. For years, I didn't like patents. I think patents are a little bit silly. If you design something there, it should be out there for everybody to use. But at some point, it became inevitable that software was going to be patented. So started playing the game.
Yeah, super interesting to hear everything from your perspective and really get to hear the journey of all the things that you're working on currently. I just want to say thank you so much, Ken, for joining me today on the Data Standard. It was so great to really hear your experiences and all of your passions really with the line of work that you have. Where can everyone find you online to connect with you?
Good question. Probably the best place is actually at Sumo. Just ping me at ken@sumologic.com. I don't have a lot of online presence. I started out long ago having online presence and built like one of the first 1,000 websites, but that was for a hobby passion, not a work passion. So the game cabinet was an early one of the first 1,000 websites, but I've never done that professionally. So you can also find me on LinkedIn under Ken Tidwell. I think I'm K.E. Tidwell if you want to go to the URL. But that's about it.
Yeah, awesome. Thank you so much. And it was such a pleasure to have you on the show. And thank you so much. I hope to speak to you again soon.
Thanks for having me. Take care.